This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recorded by Annie Coleman in St. Louis, Missouri, in April 2006. The Origin of Species by Means of Natural Selection, or The Preservation of Favored Races and the Struggle for Life. 6th London edition, by Charles Darwin. Introduction. When on board HMS Beagle as a naturalist, I was much struck with certain facts in the distribution of the organic beings inhabiting South America, and in the geological relations of the present to the past inhabitants of that continent. These facts, as will be seen in the latter chapters of this volume, seem to throw some light on the origin of species, that mystery of mysteries, as it has been called by one of our greatest philosophers. On my return home, it occurred to me, in 1837, that something might perhaps be made out on this question by patiently accumulating and reflecting on all sorts of facts which could possibly have any bearing on it. After 5 years' work, I allowed myself to speculate on the subject, and drew up some short notes. These I enlarged in 1844 into a sketch of the conclusions which then seemed to me probable. From that period to the present day, I have steadily pursued the same object. I hope that I may be excused for entering on these personal details, as I give them to show that I have not been hasty in coming to a decision. My work is now, 1859, nearly finished, but as it will take me many more years to complete it, and as my health is far from strong, I have been urged to publish this abstract. I have more especially been induced to do this, as Mr. Wallace, who is now studying the natural history of the Malay archipelago, has arrived at almost exactly the same general conclusions that I have on the origin of species. In 1858 he sent me a memoir on this subject, with a request that I would forward it to Sir Charles Lyell, who sent it to the Linnean Society, and it is published in the 3rd volume of the Journal of that society. Sir C. Lyell and Dr. Hooker, who both knew of my work, the latter having read my sketch of 1844, honored me by thinking it advisable to publish, with Mr. Wallace's excellent memoir, some brief extracts from my manuscripts. This abstract, which I now publish, must necessarily be imperfect. I cannot here give references and authorities for my several statements, and I must trust to the reader reposing some confidence in my accuracy. No doubt errors may have crept in, though I hope I have always been cautious in trusting to good authorities alone. I can here give only the general conclusions at which I have arrived, with a few facts in illustration, but which I hope in most cases will suffice. No one can feel more sensible than I do of the necessity of hereafter publishing in detail all the facts, with references, on which my conclusions have been grounded, and I hope in a future work to do this, for I am well aware that scarcely a single point is discussed in this volume on which facts cannot be adduced, often apparently leading to conclusions directly opposite to those at which I have arrived. A fair result can be obtained only by fully stating and balancing the facts and arguments on both sides of each question, and this is here impossible. I much regret that want of space prevents my having the satisfaction of acknowledging the generous assistance which I have received from very many naturalists, some of them personally unknown to me. I cannot, however, let this opportunity pass without expressing my deep obligations to Dr. Hooker, who, for the last 15 years, has aided me in every possible way by his large stores of knowledge and his excellent judgment. In considering the origin of species, it is quite conceivable that a naturalist, reflecting on the mutual affinities of organic beings, on their embryological relations, their geographical distribution, geological succession, and other such facts, might come to the conclusion that species had not been independently created, but had descended, like varieties, from other species. Nevertheless, such a conclusion, even if well-founded, would be unsatisfactory, until it could be shown how the innumerable species inhabiting this world have been modified, so as to acquire that perfection of structure and co-adaptation which justly excites our admiration. Naturalists continually refer to external conditions, such as climate, food, etc., as the only possible cause of variation. In one limited sense, as we shall hereafter see, this may be true, but it is preposterous to attribute to mere external conditions the structure, for instance, of the woodpecker, with its feet, tail, beak, and tongue so admirably adapted to catch insects under the bark of trees. In the case of the mistletoe, which draws its nourishment from certain trees, which has seeds that must be transported by certain birds, and which has flowers with separate sexes absolutely requiring the agency of certain insects to bring pollen from one flower to the other, it is equally preposterous to account for the structure of this parasite, with its relations to several distinct organic beings, by the effects of external conditions, or of habit, or of the volition of the plant itself. It is therefore of the highest importance to gain a clear insight into the means of modification and co-adaptation. At the commencement of my observations, it seemed to me probable that a careful study of domesticated animals and of cultivated plants would offer the best chance of making out this obscure problem. Nor have I been disappointed. In this and in all other perplexing cases, I have invariably found that our knowledge, imperfect though it may be, of variation under domestication, afforded the best and safest clue. I may venture to express my conviction of the high value of such studies, although they have been very commonly neglected by naturalists. From these considerations I shall devote the first chapter of this abstract to variation under domestication. We shall thus see that a large amount of hereditary modification is at least possible, and what is equally or more important, we shall see how great is the power of man in accumulating by his selection successive slight variations. I will then pass on to the variability of species in a state of nature, but I shall unfortunately be compelled to treat this subject far too briefly, as it can be treated properly only by giving long catalogues of facts. We shall, however, be enabled to discuss what circumstances are most favorable to variation. In the next chapter, the struggle for existence among all organic beings throughout the world, which inevitably follows from the high geometrical ratio of their increase, will be considered. This is the doctrine of Malthus, applied to the whole animal and vegetable kingdoms. As many more individuals of each species are born that can possibly survive, and as, consequently, there is a frequently recurring struggle for existence, it follows that any being, if it vary however slightly in any manner profitable to itself, under the complex and sometimes varying conditions of life, will have a better chance of surviving, and thus be naturally selected. From the strong principle of inheritance, any selected variety will tend to propagate its new and modified form. This fundamental subject of natural selection will be treated at some length in the fourth chapter, and we shall then see how natural selection almost inevitably causes much extinction of the less improved forms of life, and leads to what I have called divergence of character. In the next chapter I shall discuss the complex and little-known laws of variation. In the 5 succeeding chapters, the most apparent and gravest difficulties in accepting the theory will be given, namely, first, the difficulties of transitions, or how a simple being or a simple organ can be changed and perfected into a highly developed being, or into an elaborately constructed organ. Secondly, the subject of instinct, or the mental powers of animals. Thirdly, hybridism, or the infertility of species and the fertility of varieties when intercrossed. And fourthly, the imperfection of the geological record. In the next chapter I shall consider the geological succession of organic beings throughout time. In the 12th and 13th, their geographical distribution throughout space. In the 14th, their classification or mutual affinities, both when mature and in an embryonic condition. In the last chapter, I shall give a brief recapitulation of the whole work, and a few concluding remarks. No one ought to feel surprise at much remaining as yet unexplained in regard to the origin of species and varieties, if he make due allowance for our profound ignorance in regard to the mutual relations of the many beings which live around us. Who can explain why one species ranges widely and is very numerous, and why another allied species has a narrow range and is rare? Yet these relations are of the highest importance, for they determine the present welfare, and, as I believe, the future success and modification of every inhabitant of this world. Still less do we know of the mutual relations of the innumerable inhabitants of the world during the many past geological epochs in its history. Although much remains obscure, and will long remain obscure, I can entertain no doubt, after the most deliberate study and dispassionate judgment of which I am capable, that the view which most naturalists until recently entertained, and which I formerly entertained, namely, that each species has been independently created, is erroneous. I am fully convinced that species are not immutable, but that those belonging to what are called the same genera are lineal descendants of some other and generally extinct species, in the same manner as the acknowledged varieties of any one species are the descendants of that species. Furthermore, I am convinced that natural selection has been the most important, but not the exclusive, means of modification. End of introduction. Chapter 1, Part A. Variation under Domestication. Contents of this chapter include causes of variability, effects of habit and the use and disuse of parts, correlated variation, inheritance, character of domestic varieties, difficulty of distinguishing between varieties and species, origin of domestic varieties from one or more species, domestic pigeons, their differences and origin, principles of selection anciently followed, their effects, methodical and unconscious selection, unknown origin of our domestic productions, circumstances favorable to man's power of selection. End of contents. Causes of variability. When we compare the individuals of the same variety or sub-variety of our older cultivated plants and animals, one of the first points which strikes us is that they generally differ more from each other than do the individuals of any one species or variety in a state of nature. And if we reflect on the vast diversity of the plants and animals which have been cultivated, and which have varied during all ages under the most different climates and treatment, we are driven to conclude that this great variability is due to our domestic productions having been raised under conditions of life not so uniform as, and somewhat different from, those to which the parent species had been exposed under nature. There is also some probability in the view propounded by Andrew Knight, that this variability may be partly connected with excess of food. It seems clear that organic beings must be exposed during several generations to new conditions to cause any great amount of variation, and that when the organization has once begun to vary, it generally continues varying for many generations. No case is on record of a variable organism ceasing to vary under cultivation. Our oldest cultivated plants, such as wheat, still yield new varieties. Our oldest domesticated animals are still capable of rapid improvement or modification. As far as I am able to judge, after long attending to the subject, the conditions of life appear to act in two ways: directly on the whole organization, or on certain parts alone and indirectly by affecting the reproductive system. With respect to the direct action, we must bear in mind that in every case, as Professor Weismann has lately insisted, and as I have incidentally shown in my work on variation under domestication, there are two factors, namely, the nature of the organism and the nature of the conditions. The former seems to be much the more important, for nearly similar variations sometimes arise under, as far as we can judge, dissimilar conditions; and, on the other hand, dissimilar variations arise under conditions which appear to be nearly uniform. The effects on the offspring are either definite or indefinite. They may be considered as definite when all or nearly all the offspring of individuals exposed to certain conditions during several generations are modified in the same manner. It is extremely difficult to come to any conclusion in regard to the extent of the changes which have been thus definitely induced. There can, however, be little doubt about many slight changes, such as size from the amount of food, color from the nature of the food, thickness of the skin and hair from climate, etc. Each of the endless variations which we see in the plumage of our fowls must have had some efficient cause, and if the same cause were to act uniformly during a long series of generations on many individuals, all probably would be modified in the same manner. Such facts as the complex and extraordinary outgrowths which variably follow from the insertion of a minute drop of poison by a gall-producing insect, shows us what singular modifications might result in the case of plants from a chemical change in the nature of the sap. Indefinite variability is a much more common result of changed conditions than definite variability, and has probably played a more important part in the formation of our domestic races. We see indefinite variability in the endless slight peculiarities which distinguish the individuals of the same species, and which cannot be accounted for by inheritance from either parent or from some more remote ancestor. Even strongly marked differences occasionally appear in the young of the same litter, and in seedlings from the same seed capsule. At long intervals of time, out of millions of individuals reared in the same country and fed on nearly the same food, deviations of structure so strongly pronounced as to deserve to be called monstrosities arise, but monstrosities cannot be separated by any distinct line from slighter variations. All such changes of structure, whether extremely slight or strongly marked, which appear among many individuals living together, may be considered as the indefinite effects of the conditions of life on each individual organism in nearly the same manner as the chill affects different men in an indefinite manner, according to their state of body or constitution, causing coughs or colds, rheumatism, or inflammation of various organs. With respect to what I have called the indirect action of changed conditions, namely through the reproductive system of being affected, we may infer that variability is thus induced, partly from the fact of this system being extremely sensitive to any change in the conditions, and partly from the similarity, as Kölreuter and others have remarked, between the variability which follows from the crossing of distinct species, and that which may be observed with plants and animals when reared under new or unnatural conditions. Many facts clearly show how eminently susceptible the reproductive system is to very slight changes in the surrounding conditions. Nothing is more easy than to tame an animal, and few things more difficult than to get it to breed freely under confinement, even when the male and female unite. How many animals there are which will not breed, though kept in an almost free state in their native country! This is generally, but erroneously, attributed to vitiated instincts. Many cultivated plants display the utmost rigor, and yet rarely or never seed. In some few cases it has been discovered that a very trifling change, such as a little more or less water at some particular period of growth, will determine whether or not a plant will produce seeds. I cannot here give the details which I have collected and elsewhere published on this curious subject, but to show how singular the laws are which determine the reproduction of animals under confinement, I may mention that carnivorous animals, even from the tropics, breed in this country pretty freely under confinement, with the exception of the plantigrades, or bear family, which seldom produce young, whereas carnivorous birds, with the rarest exception, hardly ever lay fertile eggs. Many exotic plants have pollen utterly worthless, in the same condition as in the most sterile hybrids. When on the one hand we see domesticated animals and plants, though often weak and sickly, breeding freely under confinement, and when on the other hand we see individuals, though taken young from a state of nature perfectly tamed, long-lived and healthy, of which I could give numerous instances, yet having their reproductive system so seriously affected by unperceived causes as to fail to act, we need not be surprised at this system, when it does act under confinement, acting irregularly, and producing offspring somewhat unlike their parents. I may add that as some organisms breed freely under the most unnatural conditions, for instance rabbits and ferrets kept in hutches, showing that their reproductive organs are not easily affected, so will some animals and plants withstand domestication or cultivation, and vary very slightly, perhaps hardly more than in a state of nature. Some naturalists have maintained that all variations are connected with the act of sexual reproduction, but this is certainly an error, for I have given in another work a long list of sporting plants, as they are called by gardeners, that is, of plants which have suddenly produced a single bud, with a new and sometimes widely different character from that of the other buds on the same plant. These bud variations, as they may be named, can be propagated by grafts, offsets, etc., and sometimes by seed. They occur rarely under nature, but are far from rare under culture. As a single bud out of many thousands produced year after year on the same tree, under uniform conditions, has been known suddenly to assume a new character, and as buds on distinct trees, growing under different conditions, have sometimes yielded nearly the same variety, for instance, buds on peach trees producing nectarines, and buds on common roses producing moss roses, we clearly see that the nature of the conditions is of subordinate importance in comparison with the nature of the organism in determining each particular form of variation, perhaps of not more importance than the nature of the spark by which a mass of combustible matter is ignited has in determining the nature of the flames. Effects of habit and of the use or disuse of parts, correlated variation, inheritance. Changed habits produce an inherited effect, as in the period of the flowering of plants when transported from one climate to another. With animals, the increased use or disuse of parts has had a more marked influence. Thus I find in the domestic duck that the bones of the wing weigh less and the bones of the leg more, in proportion to the whole skeleton, than do the same bones in the wild duck, and this change may be safely attributed to the domestic duck flying much less and walking more than its wild parents. The great and inherited development of the udders in cows and goats in countries where they are habitually milked, in comparison with these organs in other countries, is probably another instance of the effects of use. Not one of our domestic animals can be named which has not in some country drooping ears, and the view which has been suggested that the drooping is due to disuse of the muscles of the ear, from the animals being seldom much alarmed, seems probable. Many laws regulate variation, some few of which can be dimly seen, and will hereafter be briefly discussed. I will here only allude to what may be called correlated variation. Important changes in the embryo or larva will probably entail changes in the mature animal. In monstrosities, the correlations between quite distinct parts are very curious, and many instances are given in Isidore Geoffroy St. Hilaire's great work on this subject. Breeders believe that long limbs are almost always accompanied by an elongated head. Some instances of correlation are quite whimsical. Thus cats which are entirely white and have blue eyes are generally deaf. But it has lately been stated by Mr. Tate that this is confined to the males. Color and constitutional peculiarities go together, of which many remarkable cases could be given among animals and plants. From facts collected by Husinger, it appears that white sheep and pigs are injured by certain plants, while dark-colored individuals escape. Professor Wyman has recently communicated to me a good illustration of this fact, on asking some farmers in Virginia how it was that all their pigs were black. They informed him that the pigs ate the paint root, Lachnanthes, which colored their bones pink, and which caused the hoofs of all but the black varieties to drop off, and one of the crackers, i.e. Virginia squatters, added, "We select the black members of a litter for raising, as they alone have a good chance of living." Hairless dogs have imperfect teeth. Long-haired and coarse-haired animals are apt to have, as is asserted, long or many horns. Pigeons with feathered feet have skin between their outer toes. Pigeons with short beaks have small feet, and those with long beaks large feet. Hence, if man goes on selecting, and thus augmenting, any peculiarity, he will almost certainly modify unintentionally other parts of the structure, owing to the mysterious laws of correlation. The results of the various unknown, or but dimly understood, laws of variation are infinitely complex and diversified. It is well worth while carefully to study the several treatises on some of our old cultivated plants, as on the hyacinth, potato, even the dahlia, etc., and it is really surprising to note the endless points of structure and constitution in which the varieties and sub-varieties differ slightly from each other. The whole organization seems to have become plastic, and departs in a slight degree from that of the parental type. Any variation which is not inherited is unimportant for us. But the number and diversity of inheritable deviations of structure, both those of slight and those of considerable physiological importance, are endless. Dr. Prosper Lucas's treatise, in 2 large volumes, is the fullest and the best on this subject. No breeder doubts how strong is the tendency to inheritance. That like produces like is his fundamental belief. Doubts have been thrown on this principle only by theoretical writers. When any deviation of structure often appears, and we see it in the father and child, we cannot tell whether it may not be due to the same cause having acted on both. But when among individuals apparently exposed to the same conditions, any very rare deviation, due to some extraordinary combination of circumstances, appears in the parent, say once among several million individuals, and it reappears in the child, the mere doctrine of chances almost compels us to attribute its reappearance to inheritance. Everyone must have heard of cases of albinism, prickly skin, hairy bodies, etc., appearing in several members of the same family. If strange and rare deviations of structure are truly inherited, less strange and commoner deviations may be freely admitted to be inheritable. Perhaps the correct way of viewing the whole subject would be to look at the inheritance of every character whatever as the rule, and non-inheritance as the anomaly. The laws governing inheritance are for the most part unknown. No one can say why the same peculiarity in different individuals of the same species, or in different species, is sometimes inherited, and sometimes not so; why the child often reverts in certain characteristics to its grandfather or grandmother or more remote ancestor; why a peculiarity is often transmitted from one sex to both sexes, or to one sex alone, more commonly but not exclusively to the like sex. It is a fact of some importance to us that peculiarities appearing in the males of our domestic breeds are often transmitted, either exclusively or in a much greater degree, to the males alone. A much more important rule, which I think may be trusted, is that at whatever period of life a peculiarity first appears, it tends to reappear in the offspring at a corresponding age, though sometimes earlier. In many cases this could not be otherwise. Thus the inherited peculiarities in the horns of cattle could appear only in the offspring when nearly mature. Peculiarities in the silkworm are known to appear at the corresponding caterpillar or cocoon stage. But hereditary diseases and some other facts make me believe that the rule has a wider extension, and that, when there is no apparent reason why a peculiarity should appear at any particular age, yet that it does tend to appear in the offspring at the same period at which it first appeared in the parent. I believe this rule to be of the highest importance in explaining the laws of embryology. These remarks are of course confined to the first appearance of the peculiarity, and not to the primary cause, which may have acted on the ovules or on the male element in nearly the same manner as the increased length of the horns in the offspring from a short-horned cow by a long-horned bull, though appearing late in life, is clearly due to the male element. Having alluded to the subject of reversion, I may here refer to a statement often made by naturalists, namely, that our domestic varieties, when run wild, gradually but invariably revert in character to their aboriginal stocks. Hence it has been argued that no deductions can be drawn from domestic races to species in a state of nature. I have in vain endeavored to discover on what decisive facts the above statement has so often and so boldly been made. There would be great difficulty in proving its truth. We may safely conclude that very many of the most strongly marked domestic varieties could not possibly live in a wild state. In many cases we do not know what the aboriginal stock was, and so could not tell whether or not nearly perfect reversion has ensued. It would be necessary, in order to prevent the effects of intercrossing, that only a single variety should be turned loose in its new home. Nevertheless, as our varieties certainly do occasionally revert in some of their characteristics to ancestral forms, it seems to me not improbable that if we could succeed in naturalizing, or were to cultivate during many generations, the several races, for instance of the cabbage in very poor soil, in which case, however, some effect would have to be attributed to the definite action of the poor soil, that they would, to a large extent, or even wholly, revert to the wild aboriginal stock. Whether or not the experiment would succeed is not of great importance for our line of argument, for by the experiment itself the conditions of life are changed. If it could be shown that our domestic varieties manifested a strong tendency to reversion, that is, to lose their acquired characters, while kept under the same conditions, and while kept in a considerable body, so that free intercrossing might check, by blending together, any slight deviations in their structure, in such case I grant that we could deduce nothing from domestic varieties in regard to species. But there is not a shadow of evidence in favour of this view. To assert that we could not breed our cart and race horses, long and short-horned cattle, and poultry of various breeds, and esculent vegetables, for an unlimited number of generations, would be opposed to all experience. Character of domestic varieties. Difficulty of distinguishing between varieties and species. Origin of domestic varieties from one or more species. When we look to the hereditary varieties or races of our domestic animals and plants, and compare them with closely allied species, we generally perceive in each domestic race, as already remarked, less uniformity of character than in true species. Domestic races often have a somewhat monstrous character, by which I mean that, although differing from each other and from other species of the same genus, in several trifling respects, they often differ in an extreme degree in some one part, both when compared one with another, and more especially when compared with the species under nature to which they are nearest allied. With these exceptions, and with that of the perfect fertility of varieties when crossed, a subject hereafter to be discussed, domestic varieties of the same species differ from each other in the same manner as do the closely allied species of the same genus in a state of nature, but the differences in most cases are less in degree. This must be admitted as true, for the domestic races of many animals and plants have been ranked by some competent judges as the descendants of aboriginally distinct species, and by other competent judges as mere varieties. If any well-marked distinction existed between a domestic race and a species, this source of doubt would not so perpetually recur. It has often been stated that domestic races do not differ from each other in characters of generic value. It can be shown that this statement is not correct, but naturalists differ much in determining what characters are of generic value, all such valuations being at present empirical. When it is explained how genera originate under nature, it will be seen that we have no right to expect often to find a generic amount of difference in our domesticated races. In attempting to estimate the amount of structural difference between allied domestic races, we are soon involved in doubt, from not knowing whether they are descended from one or several parent species. This point, if it could be cleared up, would be interesting. If, for instance, it could be shown that the greyhound, bloodhound, terrier, spaniel, and bulldog, which we all know propagate their kind truly, were the offspring of any single species, then such facts would have great weight in making us doubt about the immutability of the many closely allied natural species, for instance of the many foxes inhabiting the different quarters of the world. I do not believe, as we shall presently see, that the whole amount of difference between the several breeds of the dog has been produced under domestication. I believe that a small part of the difference is due to their being descended from distinct species. In the case of strongly marked races of some other domesticated species, there is presumptive or even strong evidence that all are descended from a single wild stock. It has often been assumed that man has chosen for domestication animals and plants having an extraordinary inherent tendency to vary, and likewise to withstand diverse climates. I do not dispute that these capacities have added largely to the value of most of our domesticated productions, but how could a savage possibly know, when he first tamed an animal, whether it would vary in succeeding generations, and whether it would endure other climates? Has the little variability of the ass and the goose, or the small power of endurance of warmth by the reindeer, or of cold by the common camel, prevented their domestication? I cannot doubt that if other animals and plants equal in number to our domesticated productions, and belonging to equally diverse classes and countries, were taken from a state of nature, and could be made to breed for an equal number of generations under domestication, they would on average vary as largely as the parent species of our existing domesticated productions have varied. In the case of most of our anciently domesticated animals and plants, it is not possible to come to any definite conclusion, whether they are descended from one or several wild species. The argument mainly relied on by those who believe in the multiple origin of our domestic animals is, that we find in the most ancient times, on the monuments of Egypt, and in the lake habitations of Switzerland, much diversity in the breeds, and that some of these ancient breeds closely resemble, or are even identical with, those still existing. But this only throws far backward the history of civilization, and shows that animals were domesticated at a much earlier period than has hitherto been supposed. The lake inhabitants of Switzerland cultivated several kinds of wheat and barley, the pea, the poppy for oil and flax, and they possessed several domesticated animals. They also carried on commerce with other nations. All this clearly shows, as Heer has remarked, that they had at this early age progressed considerably in civilization, and this again implies a long-continued previous period of less advanced civilization, during which the domesticated animals, kept by different tribes in different districts, might have varied and given rise to distinct races. Since the discovery of flint tools and the superficial formations of many parts of the world, all geologists believe that barbarian men existed at an enormously remote period, and we know that at the present day there is hardly a tribe so barbarous as not to have domesticated at least the dog. The origin of most of our domestic animals will probably forever remain vague, but I may here state that, looking to the domestic dogs of the whole world, I have, after a laborious collection of all known facts, come to the conclusion that several wild species of Canidae have been tamed, and that their blood, in some cases mingled together, flows in the veins of our domestic breeds. In regard to sheep and goats, I can form no decided opinion. From facts communicated to me by Mr. Blyth on the habits, voice, constitution, and structure of the humped Indian cattle, it is almost certain that they are descended from a different aboriginal stock from our European cattle, and some competent judges believe that these latter have had 2 or 3 wild progenitors, whether or not these deserve to be called species. This conclusion, as well as that of the specific distinction between the humped and common cattle, may indeed be looked upon as established by the admirable researches of Professor Rütemeyer. With respect to horses, from reasons which I cannot give here, I am doubtfully inclined to believe, in opposition to several authors, that all the races belong to the same species. Having kept nearly all the English breeds of the fowl alive, having bred and crossed them and examined their skeletons, it appears to me almost certain that all are the descendants of the wild Indian fowl, Gallus bankiva, and this is the conclusion of Mr. Blyth and of others who have studied this bird in India. In regard to ducks and rabbits, some breeds of which differ much from each other, the evidence is clear that they are all descended from the common duck and wild rabbit. The doctrine of the origin of our several domestic races from several aboriginal stocks has been carried to an absurd extreme by some authors. They believe that every race which breeds true, let the distinctive characters be ever so slight, has had its wild prototype. At this rate there must have existed at least a score of species of wild cattle, as many sheep and several goats in Europe alone, and several even within Great Britain. One author believes that there formerly existed 11 wild species of sheep peculiar to Great Britain. When we bear in mind that Britain has now not one peculiar mammal, and France but few distinct from those of Germany, and so with Hungary, Spain, etc., but that each of these kingdoms possesses several peculiar breeds of cattle, sheep, etc., we must admit that many domestic breeds must have originated in Europe, for whence otherwise could they have been derived? So it is in India. Even in the case of the breeds of the domestic dog throughout the world, which I admit are descended from several wild species, it cannot be doubted that there has been an immense amount of inherited variation. For who will believe that animals closely resembling the Italian greyhound, the bloodhound, the bulldog, pug dog, or Blenheim spaniel, etc., so unlike all wild Canidae, ever existed in a state of nature? It has often been loosely said that all our races of dogs have been produced by the crossing of a few aboriginal species. But by crossing we can only get forms in some degree intermediate between their parents, and if we account for our several domestic races by this process, we must admit the former existence of the most extreme forms, as the Italian greyhound, bloodhound, bulldog, etc., in the wild state. Moreover, the possibility of making distinct races by crossing has been greatly exaggerated. Many cases are on record showing that a race may be modified by occasional crosses, if aided by the careful selection of the individuals which present the desired character. But to obtain a race intermediate between two quite distinct races would be very difficult. Sir J. Sebright expressly experimented with this object, and failed. The offspring from the first cross between two pure breeds is tolerably, and sometimes, as I have found with pigeons, quite uniform in character, and everything seems simple enough. But when these mongrels are crossed one with another for several generations, hardly two of them are alike, and then the difficulty of the task becomes manifest. End of Chapter 1, Section A.